In the last video, we talked about the first two types of research designs, case studies and correlational studies. We also learned that correlational studies can show us if two variables are related, but they can't definitively say anything about whether one variable causes another. So what if causation is really what we want to know? Can researchers ever make a definitive statement that some variable X causes some change in another variable Y? They can, and this is where the third type of research design, experiments, comes in. In an experimental design, the researcher actually manipulates or controls one of the variables by randomly assigning participants to different levels or conditions of that variable. Let's look at how this would work in a couple examples. First, let's continue with our example of social media and mental health. In a correlational study, the researcher would simply measure these two variables as they naturally occur. As we mentioned in the previous video, however, this means that the researcher cannot determine which variable came first. Was it social media or mental health? Or even if both might be caused by some separate third variable, like perhaps other generational differences. So how can the researcher address this problem? In an experimental design, the way to do this is through random assignment. Here, the researcher might decide to manipulate or change people's social media use by randomly assigning participants to one of two groups. One group that limits their social media use for some length of time, say maybe 2 weeks or so, and this would be our experimental group or condition. And a second group that continues to use social media as they normally would during the same length of time, and this would be our control group or control condition. After the 2 weeks are up, the researcher can measure people's mental health and see if there's a difference between the two groups. In experimental design, the variable that is manipulated is called the independent variable. In this example, the independent variable would be social media use, because that's the variable that the researcher manipulated or changed via random assignment. The measured outcome is called the dependent variable. In this example, mental health would be the dependent variable, because participants' mental health is the outcome that the researcher is interested in measuring. Let's practice with another example. Let's imagine that researchers are interested in whether being in a positive mood causes people to be more helpful. The researchers recruit a sample of participants who are randomly assigned to watch either a funny 2-minute video clip that's designed to put them in a positive mood, or a neutral 2-minute video clip. Afterwards, participants are asked if they would be willing to donate 1 hour of their time to help another student on campus. Can you determine what are the independent and dependent variables in this study? Here, the independent variable is mood. This is because this is the variable that was manipulated or changed by the researchers. That is, the researchers changed participants' mood temporarily by randomly assigning some of them to watch a funny video and others to watch a neutral video. If the researchers were concerned about whether or not this manipulation was effective, they can include something called a manipulation check, which is just where they essentially check to see if the manipulation worked. Here, for example, the researchers might give participants a short mood questionnaire after watching the videos, just to double check that participants in the funny video group actually did report being in a little bit better mood than those in the neutral video group. The dependent variable in this study would be participants' willingness to help by volunteering to donate some of their time. This is the outcome that the researchers measured at the end of the study. Let's imagine that after conducting this study, the researchers obtained the following results. Can the researchers say that being in a positive mood caused people to be more helpful? First, the researchers would need to determine if this difference between the two groups is actually statistically significant by running a statistical test and calculating a p-value. Let's imagine that after running a t-test, the researchers obtained a p of 0.01. Think back to the earlier videos in this module. Do you remember what this means? 0.01 is less than the cutoff for significance of 0.05, so these results would be considered statistically significant. In other words, the researchers could conclude that there is likely a meaningful difference between these two groups. In other words, the results are unlikely to be simply a fluke. But what about some of the other problems we talked about in the last video, like reverse causality and the third variable problem? Are those an issue here too? It turns out not. Let's explore why. First, reverse causality is not a problem because the researchers know in what order the variables occurred. The researchers manipulated mood first, and then they measured willingness to help second. So we know mood had to come first. The same is true in our social media example. In a correlational study, remember, researchers simply measure these two variables as they naturally occur, so it's difficult to know which one actually preceded the other. In an experiment, however, the researchers actually manipulated or changed participants' social media use by restricting it for half the sample. The researchers created this change in social media habits first, and then they measured any corresponding change in mental health second. So again, the order is now known, and reverse causality is therefore not an issue. That's one major advantage to doing an experiment, where the independent variable is manipulated or controlled by the researchers. But what about those pesky third variables, or confounds? Remember, a confound is simply an alternative explanation for our findings. For example, in our mood and helping study, you might wonder if some participants were more willing to help simply because they were just more helpful people. So is that a confound or an alternative explanation in our study? Again, it's actually not. Remember that when manipulating the independent variable, the researchers randomly assigned participants to be either in the funny video or the neutral video group. In other words, participants didn't get to choose which group they were in. The researcher chose, based on a random process, such as the roll of a die or a random number generator. And it turns out that this is really important. Because of this process of random assignment, that means we should end up with generally helpful as well as generally unhelpful people in both the experimental and control conditions. This means that it can't simply be that the positive mood group helped more because they were more helpful people. If random assignment is working, then there should have been helpful people in the control group too. And this should be the case for many other potential confounds like participant gender, age, personality, etc. This is what makes random assignment so special. It essentially makes the two groups equal or the same, at least on average, at baseline. And importantly, if our experimental manipulation, in this case the videos that people watched, is the only difference between our two groups, then our experimental manipulation is also the only thing that can explain why the two groups scored differently on our outcome. So because of random assignment, experiments can effectively rule out most potential confounds or alternative explanations for a result in a way that correlational studies simply can't do. For this reason, experiments are the only type of research design that can truly support a statement about causation. So why don't we just conduct experiments all the time? Why do we ever conduct correlational research? Well, it turns out that not all variables can be ethically manipulated. For example, researchers can't randomly assign some people to be a different age or randomly change their socioeconomic status. They also can't ethically force some participants to engage in a treatment or behavior that they believe might ultimately be harmful, like smoking. Because not all variables can be randomly assigned, it's therefore not always possible to conduct an experiment on the variables that we're interested in. An area where this is especially relevant is in regards to research on diet. You might be aware of a lot of research looking at the connection between different types of diets and various health outcomes. I know I certainly read about this type of research a lot. Technically, it is possible to change somebody's diet by randomly assigning some people to eat a low-sugar diet, for example, or randomly assigning some people to limit their consumption of red meat. And there are some nutrition studies that do this kind of experimental work. However, this is also really hard and expensive to do, much more difficult than randomly assigning some people to watch a funny or neutral 2-minute video, or even randomly assigning some people to abstain from social media for a short duration. Because of this, most nutritional research is correlational in nature. And remember that correlational studies, no matter how well done, can never definitively show causation. So the next time you read about a food that supposedly causes cancer or a fad diet that supposedly reduces cholesterol, take it with a grain of salt, pun intended.